Greener and healthier India. In the year 2001, IGBC was formed by CII with a vision to enable sustainable built environment for all and facilitate India to become one of the global leaders in sustainable built environment by 2025. Thanks to the support and involvement of all stakeholders, India stands tall in the global green building map. IGBC is now successful in taking green principles to larger built environment, such as cities, townships, schools, villages, and metros. IGBC has designed green building rating systems to suit various building types. IGBC green building rating systems are a perfect blend of ancient architectural practices and modern technological trends. IGBC, with the support of all the stakeholders, has demonstrated a clear business case for green buildings. Today, constructing a green building is technically feasible and economically viable. Various building types are going the green way with IGBC. IGBC local chapters and are playing a catalytic role in the spread of the green building movement across the country. IGBC estimates that by the year 2030, the market potential for green building products, technologies, and equipment would be about USD 300 billion. To facilitate wider adoption of green building products, IGBC has launched the Green Product Certification, Green Pro. Having gained rich and varied experience in handling the modern green building movement, the Indian industry is well poised to set new global benchmarks. Partner with IGBC in building a greener and healthier India. For more on green buildings, visit us at www.. IGBC, facilitating a greener and healthier India. In the year 2001, IGBC was formed by CII with a vision to enable sustainable built environment for all and facilitate India to become one of the global leaders in sustainable built environment by 2025. Thanks to the support and involvement of all stakeholders, India stands tall in the global green building map. IGBC is now successful in taking green principles to larger built environment, such as cities, townships, schools, villages, and metros. IGBC has designed green building rating systems to suit various building types. IGBC green building rating systems are a perfect blend of ancient architectural practices and modern technological trends. IGBC, with the support of all the stakeholders, has demonstrated a clear business case for green buildings. Today, constructing a green building is technically feasible and economically viable. Various building types are going the green way with IGBC. IGBC local chapters and are playing a catalytic role in the spread of the green building movement across the country. IGBC estimates that by the year 2030, the market potential for green building products, technologies, and equipment would be about USD 300 billion. To facilitate wider adoption of green building products, IGBC has launched the Green Product Certification, Green Pro. Having gained rich and varied experience in the modern green building movement, the industry is well poised to set new global benchmarks.
very warm good afternoon to you all. My name is Arpan Johari, and I'll be talking to you about adaptive. Reuse. The case study is for our own office, AW Design, which is located in Ahmedabad. So this is an IGBC Platinum rated green interiors project. We attempted and achieved 90 points. And our main mantra here was to build green and to prove that it makes financial sense to build green. So adaptive reuse, how do we do it in an architect studio? Well, for starters, the fit out that we did was done by rehoming materials which were destined for end of life or for disposal. So by building out of waste again, we saved money. How did we choose what waste to build from? Let us have a look at this simple graph. You can see the bar in the green says 26%. It is for 2030 energy consumption footprint of all buildings constructed between 2015 to 2030. So about 900 billion square feet spanning 15 years. The balance is building materials, 74%. So building materials have a huge impact on energy consumption footprint. Moving on to the next slide. Here again, building operations and the sector-wise carbon dioxide emissions between 2015 to 2050 is only 10% for operations and 90% by building materials. So you can imagine how big of impact building materials have on the carbon dioxide. Building materials and construction is about 49%, 51% is operational carbon, building operations. So this is an interesting figure that at least 49% it is still slightly less than operational carbon. What you must bear in mind here is that this 49% is set out only over a span of 1 to 3 years. Right? So when the material is extracted, stored, or when the building is built. The operational carbon and the building operations will span the design life of the building, 30 years, 40 years, 50 years. So when you start putting it in that context, you suddenly start seeing how much of embodied carbon is really reflected in building materials and construction. So what is this word embodied? Embodied energy is the sum of all energy needed to produce any product, as if the energy was incorporated or embodied into the product itself. So if you, for any product that you define, the energy that has gone into it right from extraction, if you look onto the left-hand side of this graphic, where it says raw material extraction to manufacturing to transportation to construction, use and maintenance, and end-of-life management, everything consumes energy. So that is what embodied energy is. Having a lower embodied energy or choosing materials with lower embodied energy allow you to have a lower carbon footprint on the planet. So what material is the greenest to build with? There is a huge plethora of materials out there. So according to embodied energy and these 5 parameters which we have here, total energy use, greenhouse gas index, etc., you can see these graphs. The guy in the orange over here is the least consuming entity. And that orange figure is wood. So wood uses very less energy to produce. It has a very less greenhouse gas index. Air pollution index is low, solid waste is low, ecological resource impact use is low. So does this mean we go out chopping wood and trees? No. But it still means that wood is a more sustainable material than steel and concrete. So we did not chopping trees and bringing wood in for our construction. We wanted to use wood-based material. We wanted to use plywood. And compared to normal wood, when you have plywood, you have already applied chopping of the tree, you have already applied processing, pulp making, manufacturing, sheet drawing. So we were worried that what will be the carbon footprint, the embodied energy of this product. So the embodied in this plywood is still very low compared to that of aluminum or clay or PU foam or anything else. So plywood was, or plywood-based materials were the materials of choice for us. And this is when we could see our material palette forming. And at this point, when we started thinking of materials that we use, plywood veneer again, which is a flitch of a tree bark mounted on plywood, MDF, which again is a sustainable way of using wood, aluminum section, some glass, some tiles, soft boards, and MS. So when we started putting values of recycled content in them, we were already doing 27 plus percentage, which was good enough for us to start thinking of an IGBC rating. But we wanted to do even more than just buying eco-friendly wood-based products or certified wood products. We just did not want to use any virgin material for our fit-outs. We wanted to make our fit-outs completely from waste. And this is the point we decided that we will do adaptive reuse of old materials. And you all must have seen the reduce, reuse, and recycle, the 3 R's of material use. And I'll put them in a greater context as they allow us to achieve greater efficiency in the use of resources as we go along. So as a team, we sat down, we discussed what should be our vision. How do we achieve this? Do we go out to every vendor and say, please give me some waste plywood pieces that you might have? That was not very sustainable for us. Or we go out to people and say, please give us a little bit of waste veneer. We didn't want to do that. We wanted to have a smaller carbon footprint. We used to reuse and repurpose construction materials. We used to keep it simple. Capital and operational expenses for our office to be low. And we also want to emphasize that green materials are available in the market. There's no need to reinvent the wheel. It would have been a different case 10, 15 years ago, but now enough is available for you to get on with. And we wanted to have fun and learn while we were doing it. So this is the flowchart of a conventional construction methodology. On your left, you see earth and an arrow, which extraction is shown by that. Material is built, from material components are built, and from component the building is built. When the building is done, at the bottom, you see disposal. What we wanted to do was have a sustainable approach to fit outs of our office. So in the material loop itself, we wanted to prevent any unnecessary usage. We want to reuse the, and if there were any other